Assalamualaikum warahmatullahi wabarakatuh to Dr. Zulaika and to all my fellow friends. Hi everyone. We are given a task to doing mini project under title water quality. Let me introduce about the mini project first. This mini project is designed to replace the face-to-face laboratory activities during COVID-19 pandemic, where the students are not allowed to enter UITM because of MCO by government. This group assignment is designed to ensure that the learning outcomes are achieved toward the program outcome attainment set for this course. This project involves a water quality assessment based on the evaluation of the physical, chemical, and biological characteristics of water. It is most frequently used with reference to a set of standards in which the compliance can be assessed properly. The standards are used to assess water quality, which relates to drinking water, the safety of human contact, and the health of ecosystem. For this mini project, our group purposed to apply physics phenomenon known as capillary action for design the purification system. Capillary action, sometimes we call capillarity, capillary motion, capillary effect, or wicking, is the ability of a liquid to flow in narrow space without the assistance of or even in opposition to external force like gravity. The effect can be seen in the drawing up of liquid between the hairs or paintbrush in a thin tube or porous material such as paper or plaster. In some non-porous material such as sand and liquefied carbon fiber or in biological cell. It occurs because of intermolecular force between the liquid and surrounding solid surface. If the diameter of the tube is sufficiently small, then the combination of surface tension, which is caused by cohesive within the liquid, and adhesive force between the liquid and container wall, act to propel the liquid. Instead of using filtration method for purification system as commonly used, we use the capillary action to show how it works and effectiveness it is. We will determine suitable parameter to be analyzed that will justify the effectiveness of this purification system. So that's all about the introduction of our mini project titles. Let's we talk about our objective. Okay, the first objective is to purpose the significant physical water quality parameters to measure the effectiveness of the design water purification system. Second, to analyze data and interpret the result of the water quality experiment. And the last, to work as a team in organizing and carry out experiment and in the preparation of technical report and presentation. The objective that have been determined just now is because of our problem statement. The problem statement is clean water is a necessity to every living organism. But various human activities, however, can lead to various pollution being emitted to the environment and thus pollute the surface water resources. The apparatus and materials that we use to carry out this experiment is, of course, water. The water that we take is tap water, rainwater, and also lake water. And we also use distilled water and beaker or clear container, clean cloth or tissue paper, and pH meter. And lastly, we use total dissolved solid and electrical conductivity water meter, TDC, and EC meter. To do any experiment or project, we must have the procedure. Our procedure is, the first one, water samples were collected. The water collected was tap water, rainwater, and also we get the distilled water. The second one, the reading of pH scale for water sample was taken by using pH meter. And the third one, the reading of total dissolved solid for water sample was taken by using EC meter. And then we using the distilled water for cleaning process before taken reading from another water sample to make sure the validity of data. After that, the water sample were poured into clean container A, and then place the container A that containing water sample at higher place and another empty container B just below it. Cloths or tissue papers we use to connect between container A and container B, and we wait until the water sample was transferred to empty container B from container A, and then we took the reading of pH scale in container B by using pH meter, and then we also took the reading of total dissolved solid in container B by using TDS meter, and then we also took the reading of electrical conductivity in container B by using EC meter. After that, all the reading was recorded and compares the data obtained. All steps were repeated by using another water sample. So that's all about our mini project explanation, and the experiment were conducted by my friends. Thank you.
Assalamualaikum and very good day. My name is Muhammad Arif, and today I will show you how to conduct this experiment. Before we start, let me know about the material and apparatus that we need to prepare. So let's get it. This is a very simple experiment, and we know what the material we are use. Firstly, we have water sample from tap water. Second, the rainwater. Lucky, I get to harvest it. And the third, the lake water. I get this lake water from the lake near at my house. Okay, next let's we look for the apparatus. I have a clear beaker. Tissue, and of course our meter reading, TDS and EC reading, pH value reading. This meter reading we can find it at Lazada and other online retail. Okay, now that we get started our experiment, firstly we need to put our water sample into the beaker first. Yeah. Make sure almost full the beaker. This one for the rainwater. And this for the lake water. Okay, and now we will read for the pH meter reading TDS reading and EC reading before we start conduct our experiment. Now I will show how to get the reading for pH value using this pH meter. And now we proceed to take the reading of pH value, TDS and EC value before we proceed with the experiment. And then we read our first sample water, tap water. Remove the cap and switch on the button, and then put it into our water sample. Make sure we read the reading after the numbers do not change. Okay. Okay. Now we proceed to find the value for TDS and EC by using TDS and EC meter. First of all, switch on the meter. As we can see on the screen, we have a value of in this meter in the mode of EC. To find the EC, we can change by using by push the button of shift. Yes, they change to ppm to get the total dissolved solid, and we put it into the water, same like we put the pH meter, and find out the reading. And then we proceed with our experiment. We need to fold our tissue like this. We can use tissue paper or clothes to make sure it's very clean, because it will be used as a filter item. And then we fold it like this and put like this. As you can see, the water already transfer from the water sample beaker into the empty beaker. So wait for a few moments. Okay, after a few moments, we can see water already transfer to the empty container, and then we proceed to take a reading for pH value, TDS and EC, same like we do it before. Alhamdulillah, we are done with our experiment. We already obtain our data, the reading of EC, TDS, pH value before and after experiment. We will analyze the data and discuss it in discussion and conclude either this purification system is suitable to obtain a good water quality. This is a certain precaution we need to make sure the tissue paper or clothes that we use as the filter item mediums or capillary action, make sure it's very clean. Actually, this idea come from the survival tips, where if you want to find if you find you want to get clean water in the jungle of other resources, water resources, you can use this method to filterize the water. That's all for today. Thank you for watching. See you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mahfuz, and I'm a part of this group for our environmental engineering laboratory mini project based on the purification system. And for my part, I would like to be discussing the discussion for this mini project. So basically, we have the three tests, which are the pH test, the total dissolved solid test, and lastly we have the electrical conductivity test. So I will give a brief explanation as to what the discussion is about. Okay, so basically we tested on three types of waters, which is tap water, rainwater, and lake water. And just to let you know, pH has a range of from 0 to 14, and whereby the indicator primarily is based on 7, which is called neutral. And anything which is less than 7 is considered acidic. Anything more than 7 is alkaline. So for tap water, it should primarily be around 7 because it is neutral, first and foremost. Yet that cannot be said regarding rainwater, because as we all know, we are living primarily based in the city, with pollution, from air pollution to water pollution to sound pollution to every sort of pollution we have in the city. So this causes atmospheric pollution. So whereby atmospheric pollution, it causes the rainfall to become acidic, and it will fall down as rainwater. Sorry, as acid rain, which can be harmful to humans. It's funny how we are the cause of acid rain, yet we will get the brunt of it, but that's life. And for lake water, is depending on what flows through it. For example, if it's sewage waste, it should be in the range of 6 to 8, based on what I found out. And for waste from factories, primarily it will be more of an alkaline solution, regarding what kind of metals they deal with, such as mercury, this and that. So it causes the waste to be alkaline, and if the waste is flowed through until the lake water, and the lake water will show a pH value of, let's say, more than 7, which is alkaline. Moving on to the total dissolved solids. For your information, total dissolved solids are primarily in groundwater sources or surface that is under the influence of groundwater or runoff. They are not visible to the human eye, and you should consult a qualified water treatment professional for advice on testing and treatment equipment if you suspect they may be present in your water. So the ideal total dissolved solids for water, as per the Canadian drinking water, is 0 to 170 ppm. For recommended is less than 500 ppm, and for the unacceptable is more than 1000 ppm. So you all know TDS, which is total dissolved solids, is made out of inorganic salts and small amounts of organic matter. Moving on to the electrical conductivity, refers to the ability of water to conduct electricity. The conductivity of water is an electrical measure of the amount of inorganic salts in a solution. As shared and mentioned above in figure 3, it shows the electrical conductivity range indicator. EC, electrical conductivity, is measured as it's one of the most frequently measured and useful water quality parameters, as it is a fairly constant indication of water quality. It also can be an early indicator of water change because of evaporation, pollution, or chemical addition, groundwater seepage. So, with these three tests, which are the pH value test, the TDS total dissolved solid test, and the EC, the electrical conductivity test, these tests will ensure the purity or the clarity of water for safe use of, well, be it drinking water or to use in factories or as a catchment area. So I hope this clarifies the discussion based on this project. With that, I thank you.
As the conclusion, we use three simple tests for our mini project, which is a pH value test, a total dissolved solid test, and also electric conductivity test. The pH value test is for us to measure the pH value of the water sources, uh, whether it's acidic or basic. So the total dissolved test is to determine the amount of total dissolved solid in the water, and the electric conductivity test is to determine the impurities of in the water, which means the higher the impurities, the better the water at conducting electric. So supposedly, tap water had to be the most safe and suitable for drinking water because it has the neutral pH value, which is 7, and also have low impurities, and also should have a lower total dissolved solid.